Okay, hi everybody. This is the Math 20-1 Radicals and Absolute Values review. This is question 8J. I just have to combine these factors together, these terms together, simplify this as much as possible. Now, I am going to run into a little bit of an issue here if I don't get clever with this. The first one here is 7 halves. I'm just going to put those together. Times the cube root of 1,024. Now, I know that 1,024 is honestly 2 to the 10. Okay, I am not going to write that out 10 times. That's going to be a waste of space here. But I know that this is 2 to the 10, and I'm going to come back to this in a second. We'll talk about what's going on here. This one right here, plus 5/12 times the cube root of, okay, well this one we might be able to write out here because 2,000 is going to be 2 times 1,000, and 1,000 is just 10 times 10 times 10. So 2 times 2 times 2 times 5 times 5 times 5. Okay, I'll deal with that in a second here. Minus 3 times the cube root of, okay, 686. Now I got to play with 686 a little bit. Divide by 2, divide by 3, oops. Oh, I'm sorry. 686 divided by 2, divide by 7. So this is going to be 2 times 7 times 7 times 7. And then plus the cube root. Now so this is going to be 1/8 times the cube root. Now here's another one where I'm going to economize a little bit because I know that 128 is 2 to the 7. Now if you don't know that off the top of your head, if you just play with that a little bit, just divide out 2's, you'll see that there are 7 factors of 2 in 128. Now, let's think about how this works. I've got 10 2's here, and I'm looking for groups of 3. Now just think about that. If you pull out or circled groups of 3, you would get 3 groups of 3 with a single 2 left over. So I already know that I'm going to be left with a single 2 underneath there. And I'm going to pull out 3 2's here. Now, one of those 2's is going to cancel with the 2 in the denominator. But I'm still pulling out 2 other 2's. So I've got a 7 times 2 2's is going to be 28. So 28 cube roots of 2. Now again, just to reiterate, I've got 10 2's there. I'm looking for groups of 3. There are 3 groups of 3 2's, which gives me 1 left over, and I can pull out a single factor of 2 for each of those groups of 3. Here, it's a little bit more visual. I've got a group of 3 2's there, I've got a group of 3 5's there, so I'm going to pull out a 10. If I pull out a 2 here, it's going to cancel with the 12 here, so this will be like 5 over 6, and if you pull out a 5, this will be 25 over 6 times the cube root of 2. Okay. Now I'm going to move on. This next one here, there's a group of 3 7's. I'll pull that out front. So this will be minus 27 cube root of 2. That one's I don't know why I said 27. That's not 27. That's 21. Sorry, there's a 3 out front, and I pulled out a 7, and you multiply those together. Now, plus. Now let's take a look at this. 7, 2 to the 7. I've got 7 2's underneath there, and I'm going to circle groups of 3. Well, I'm going to be able to circle 2 groups of 3 underneath there, which is going to leave me with a single cube root of 2 left over. For each of those 2, for each of those 2 groups of 3, I'm going to pull out a single factor of 2, which is going to put me at a 4 on top, 4 over 8. And I was going to put 1 over 8. That's just crazy talk. It'd be 1 over 2. Okay. So now, look at that. All of these are cube roots of 2. So I've got 28 cube roots of 2. And I'm going to add 25/6 cube roots of 2. Then I'm going to subtract. Okay, I'm going to subtract 21 cube roots of 2. And then I'm going to add half of a cube root of 2. Now, I like leaving things as fractions here, so looks like the denominator here is going to be 6, but it will simplify down a little bit. This is going to end up being 35 thirds cube roots of 2.